This problem started out as a complex fraction, so we had to treat the numerator as its own problem and this big denominator as its own problem. So this first step I did here was find the common denominator, and whatever I multiplied by the old fraction by to become the new denominator, I had to multiply the numerator as well. So if you ever need to, in this process, pause and look at my work, make sure you do that so you can look at each little part. But I had to times this z by an 11z, and I had to times this 8 by a z plus 8 to become, so that they will have a common denominator. In this separate problem down here on the bottom, the common denominator was 3z times z plus 8. Because if I factored this 3z plus 24, I'd get 3 and z plus 8. So that's where I got the 3 from. The z was from over here, and then the z plus 8. I kept it in factored form there. So then I had to times each numerator by whatever I needed to become the new numerator. So that left me with this problem here. After I multiplied through, I got the 8z plus 64 here. I kept the denominator in factored form. I didn't distribute that through. The numerators, though, like that's how I got my z squared, my 12z, and my 96. Then, since it was a big fraction problem, and I had already simplified my big numerator as far as it could go and my big denominator as far as it could go, then I needed to do the keep it, change it, flip it. So I kept my first fraction the same, changed my divide to a times, and flipped my second fraction over. Then I saw some things would cancel, my z plus 8s and my z's. That's why I kept it in factored form, so that I'd be able to cancel things if they were able to be canceled. So that just left me with a 3 times this other numerator here, 11z squared plus 8z plus 64. And down here in the denominator, I still had the 11, and I still had the z squared plus 12z plus 96. So then I just needed to distribute this through, distribute the 11 through, and I got my final answer here.